Welcome back. Don't forget about greatest common factors. We always want to look to see if we have a greatest common factor before we factor the rest of the polynomial. So far, we haven't really had to worry about it too much, except when we used it within the factoring by grouping. But sometimes it's helpful to do that right at the beginning. For instance, if you have 5x squared minus 45, at first you may look at that and go, well, 5's not a perfect square, so I'm done. Well, wait. Can you pull that 5 out? And we can. It's a factor of both 5x squared and 45. So we can factor that out, and we get 5 times x squared minus 9. Now we have a difference of 2 squares because 9 is 3 squared. So we can factor that as 5 times x plus 3 times x minus 3. Okay, let's look at 6q squared minus 14q plus 8. I do believe we can factor a 2 out of each one of those, and so we've got 3 squared minus 7q plus 4. And then if you use the AC method, you can see that 3q squared minus 7q plus 4 factors out to be 3q minus 4 times q minus 1. For part C, we've got negative 5z squared plus 20z. So let's see, we can bring out the negative, the 5, and a z. So we've got negative 5z, and what we have left is negative 5z squared divided by negative 5z is z. 20z divided by negative 5z is negative 4. So we have negative 5z, that negative's kind of hard to see, but it's right there. Negative 5z times z minus 4. All right, so let's look. We've got 12p squared minus 21p plus 3. We can pull out a 3. And so we get 3 times 4p squared minus 7p plus 1. Well, you know what, guys? You can sit there, you can play with AC, and you go, okay, AC would be 4. So we're looking at 1 and 4 or 2 and 2. None of those are going to combine together to give you negative 7. So this little trinomial is prime, but the factorization of the whole big trinomial is 3 times this little prime trinomial. So we're done. So that was it. And we knew we were done because if you use the AC method and you try to factor this, nothing works. All right, so our goal was to be able to solve equations. So let's move on to solving equations. Let's use these factoring techniques along with the zero product property to solve some quadratic equations. So the first one we're going to look at is 3x squared plus 10x minus 8 equals 0. And then we'll move on to 5p squared minus 16p plus 15 equals 4p minus 5. Okay, so for part A, we write the original equation, and then we find A, B, and C. We use the AC method, and we factor, and we get 3x minus 2 times x plus 4. If you need to stop and actually work through the AC method, that's great. Absolute value of AC there is 24, and the two that work are going to be 2 and 12, because since C is negative 8, we want to subtract to be 10. And so you would have 3x squared plus 12x minus 2x minus 8, and you would work from there, and that is going to give you 3x minus 2 times x plus 4 equals 0. If you want to pause and work that out, go ahead. Okay, once you get to this point, you set each fact equal to 0. So 3x minus 2 equals 0, or x plus 4 equals 0. So we're going to solve each one of these. So for 3x minus 2 equals 0, you add 2 to both sides, and that gives you 3x equals 2. And then you divide by 3 to get x equals 2/3. For x plus 4 equals 0, you subtract 4 from both sides, and you get x equals negative 4. Okay, so we know we're done because we've got our two values that x can equal. Okay, on this one, 5p squared minus 16p plus 15 equals 4p minus 5. We're going to want to use the zero product property, so we have to equal 0. So we need to subtract everything over to one side. And so I would subtract the 4p over, subtract negative 5, which means add 5 to both sides. So I get 5p squared minus 20p plus 20 equals 0. Then I factor, so I can pull out a 5. Actually, because this is an equation, you can go ahead and just divide each side by 5. Doesn't matter which way you do it, but we can divide each side by 5. And that's going to give you p squared minus 4p plus 4 equals 0. And now we can factor. and that is a perfect square trinomial where we have p minus 2 quantity squared equals 0, and so we use the zero product property and we get p minus 2 equals 0. Solve for p and we get p equals 2. Now that is one of those double zeros. Okay, so you want to make note of that. That's a double zero because it came from two factors that were identical. Okay, so I want to give credit where credit's due. I do use Larson Algebra 2 from Hope McDougall, and they are generous with providing PowerPoint slides that I can edit and use just the way I want. And here's what the book looks like. Here's my source of the video presentations. And so I just want to say thank you, McDougall Littell Class Zone. For my students, go ahead and practice, do the problems to try on your own, and we will go over them when we get to class. If you really struggle with factoring these trinomials, come in and see me and we can go back over some of these problems. All right, see you later.